Then we also can do something that is more fanciful. We are not limited to only one expression, like greater equal to 7. We could also ask what seems to be more complicated expressions, but so long as they are able to be written down with mathematical expressions like ampersand and vertical bar for or this or that, and tilde, the tilde sign, like for me it's the key to the left of one. The tilde sign means inversion. So if it's true, it becomes false. If it's false, it becomes true. And don't underestimate these simple combinations because they can do wonders. So for example, if our goal is to select all the rows whose column B values are between, right, between 3 to 5 inclusive, 3, 4, or 5. And, all right, not only that, and whose corresponding column A has a 2, has a 2. So for example, we might give to a vaccination priority shots of whatever special processing to people whose ages are between 30 years old to 50 years old, inclusive. All right. But if you are single, then we are not having no children or married but no children, then maybe you can be a bit more tolerant in terms of waiting a bit longer. But those with children, we would want to give special priority or special processing. So if you have two kids, let's for now just say two kids, right? Not just one, but two kids, then not only that your age is between 3 and 5, like 3 and 5 will be here, 4 to 5, 3, 4, 5. So all these yellow boxes. In addition, that's where this overlaying yellow box comes. And also your number of children is equal to 2. All right. Then in that case, we will do special processing for you. So that's the reason why we want to combine using an and, because it's also an English way of saying and also, right? Now, how do we express this? So fortunately, using the and, or, and not, we can just say df6b greater equal to 3 and df6b less than equal to 5, right? So 3, 4, and 5. And we put brackets here because let me just caution you here, all right? The ampersand, the vertical bar, and the tilde, they are having some sort of a priority that sometimes can be confusing, and it's never quite exactly clear. For example, the ampersand could end up sucking in the 3 and the df6.b, something like that, and then you start doing weird things. That may not result in syntax error, so Spider and Python will not warn you, and you get some sort of the data frame coming out, surprisingly, without any error. And it's dangerous because we are not sure how Python had actually interpreted it silently without error. So the best thing, as I always practice, is to make sure that all the comparisons are protected by the brackets. Okay, so I want to make sure that the column is greater than equal to 3 and less than equal to 5. And within the and, I also emphasize that this is done first with the protection brackets. Okay, do it first, then check. And also that your df6.a, the number of children, is equal to 2. Okay, some of you may understand that, well, actually, if it's ampersand and ampersand, it doesn't matter, right? It's true, it's associative, so you can bracket either way. But let's be clear what we are trying to say, because when you bracket these two together, you are saying like, oh, the range is between 3 to 5, right? But if you bracket df.6.b and .a like that, the meaning is not so clear anymore, even though mathematically it's equivalent. So try to practice clear way of expressing the logic and mathematics, even though alternative ways will result in the same values, but becoming less readable and less clear. Okay, so when we do this, we end up having or generating another mask, right? Another series that contains only true false values, and we call this a mask series or a data frame series. So it's a mask series in this case because we extracted columns only. and the resulting true values are only for rows 3 and 4, row labels 3 and 4. So end up we will get this data frame instead. So if we base our content on TF6, we'll get a data frame consisting of only row labels 3 and 4. And the result is actually, the dot index is actually 3, 4, not 0, 1. It will follow whatever is being extracted. So that we know, right, that from the original data frame, it was actually row with labels 3 and 4. And of course, if we want to reset the index, it's very simple, right? So just equal to range 2. That would. Then another way, of course, the corresponding thing is that we like to know 3 and 4. We don't care about the content. We like to know which row labels. Then we saw how we can do it either way. But here I will just show you another. One of the ways is, of course, dot index and then put in the same mask. But that results in a dot index type. The dot index type is basically a series, but specifically reserved for use in the index position. That's just by Panda's way of making things even clearer, right? So anyways, we can always force list it with a list bracket, open close bracket, to force convert the index, but actually a series, a Panda series, but a series is an array, right? Array is just a list in Python. So force convert it into a list in Python. And now we have the indices stored as integer list in Python, where we are back to familiar territory. We can always say for I in this list, perform special operations. Yeah, so really very easy to do very complicated, fanciful stuff here. Okay. Now, one more level. We can also do the true-false arbitrary selection using a data frame mask. Something we have seen earlier on, right? We have tried out by handcrafting true, false throughout to create another data frame manually. Now, that might seem a bit dubious. Why would we do that? Sometimes, yes. Sometimes we are really our no choice because it's very human-based kind of decision. It is very subjective. It is about which one do you like kind of thing. Then, of course, we say I like this. It's very subjective. But to the extent that what we are selecting may satisfy certain mathematical operations, and that actually deals with a lot of situations like those who are seniors, right? So it's greater than a certain age. Those who are toddlers, young adults, then between certain age and less than certain age. Those who stay far away from city center, okay, distance to city center is greater than certain kilometers. So you see, a lot of these real life scenarios can actually be expressed mathematically. So that's why this is an important part of our analytics discussion. So boil down to the core essence. The idea is just use a mathematical expression to generate a data frame mask. That's all. Because you know that once you have the mask, you just stick in the data frame data, square bracket, select based on this mask, finish, right? So how do we generate the mask? Now, so here we have this very naive questions. We're not interested in the data, nor the data frame. We're interested in how many. How many cells in this data frame have values 6 or more? Okay, that means this data frame basically has the same data type. All the values are basically having numbers, and we're interested in counting, not a specific cell, but just counting. Any cell that is 6 or more will count as 1. Okay, that sounds like easy, right? And it's a very simple idea. Naive way, for R in row, for C in column, is the df dot at row comma column. If it's greater than 6, count equals to count plus 1. Otherwise, skip. But again, that's putting 4 as the focus. So what we do here is very simple. df6 greater equal to 6. Finish. That generates this mask. All right, df6, the whole data frame, cell by cell, check. Is it greater equal to 6? Finish. How do we know it's cell by cell and not column based or row based? Well, because we are referring to the whole data frame. We didn't say dot anything to make it a column. We didn't say axis equals to whatever, right? No, we didn't. So it's entire data frame cell by cell. So generating the mask, very simple. Greater equal to 6, finish. All right. Next, next, we perform using df6 underscore L sum. Just perform a sum. We say this whole data frame dot sum. Now, dot sum is an aggregating function. Aggregating function means it takes a lot of numbers, but churns out only one number. That number can be total. That's an aggregating function. You add up all the numbers, give one total. That can be average. It can be minimum. It can be maximum, median, So all these are aggregating functions where they take in a lot of numbers and churn out only one number. So is this function called sum, which is supported by pandas. So when you say dot sum, it will perform a column sum vertically downwards. How come? Because its axis defaulting to 0. So if you don't specify, it is column sum. If you like to do row sum, simply say dot sum bracket axis equals to